Hello everyone, welcome to upGrad.com's Python tutorial for beginners. This course provides a detailed understanding of Python and its various concepts using industrial use cases and easy to understand approaches. You are also welcome to join our industry-oriented programs on this course. For more details, please find the link in the description below. This video session is a second part of this Python series. If you have not watched the first session, it is recommended to click on the I button on the top right corner of the screen. So let us start with today's session, which is Python data structures. In this session, we'll be understanding what data structure is and why it is important to understand data structures for data processing. Let us start with the agenda of today's session, everyone. In this session, we'll be starting with understanding Python data structures. I'll be telling you about what data structures are and what are the kind of data structures we have in Python. We'll be talking about the primitive and non-primitive data structures. Then we'll be talking about strings and string slicing and its importance as well. Then we'll be talking about the most fundamental data structure of Python, which is list, set, tuples, and dictionary. Apart from that, we'll be discussing some of the scenarios about choosing the right data structure for the right situation. Let us start with understanding Python data structures. Data structures are the fundamental concepts of computer science. They help you in writing the efficient programs in any programming languages. What is data structure? Well, data structure helps you in storing and processing the data with an extraordinary speed and accuracy. It is highly essential that the data is stored efficiently and can be accessed fast. Also, the processing of data should happen in the smallest possible time, but without losing any accuracy in the computation. So, data structures are a way of organizing and storing the data so that they can be accessed and worked with efficiently. Now, the concept of data structures revolves around data. Yes, you heard me right, data. So, we have different kinds of data or different natures of data. Some data are smaller in size and some data are huge. Some data are repeated in nature, for example, the name of the employees, whereas some of the data is non-repeated in nature, such as the employee ID. Now here, if we have such kind of information or such data, then the challenge is to store the data as well as process the data. So let us take an example here, everyone. So this, so let's say this is a simple word for all of us. It's a very simple data. So here, this data can be in multiple lines as well. For example, let's say Jay, Sunil, and Rahul. So here we have individual data or the scalar data means the single value. And here we have set of values. So here, the challenge is how will you store the individual data or the set of values. So choosing the right storage helps you in achieving the maximum performance. So in Python, we are provided with some of the data structures which will help you in storage and processing. Now, processing can be vastly classified into these common operations. So once we have stored data in a container, then the operations that we later perform on that container would be adding a new element in the container, deleting any specific element for a container, traversing through each element of that particular container, sorting the data, or searching for a specific element in a given container. So these are some of the common list of operations that we perform on a data structure. Let us start with the very basics of data structure, and here we'll be not talking about the groups of values. First of all, we'll be talking about the individual values. All right. So here, the primitive section. The primitive section or the primitive component or the primitive data structures are those data structures provided in Python which helps you in managing the individual values. For example, integer. So let us take an example of a container here called num with the constant or the value 100. So it is an integer variable or an integer data structure. Similarly, the price would be the float data structure. Float means the decimal values. Then for strings, strings is basically the group of words here. So for example, message equals to amazing Python. So here, message is a string variable. Strings are identified by group of characters or group of alphanumeric characters as well. And strings are always in single or double or triple quotes. Then we have another data structure called Boolean, which represents true or false. So for example, is user logged? So this condition can be represented in the form of a true or false state. So is user logged? True means the user is logged in, let's say, you can say it's a imaginary situation. And if the value of is user logged is false, means the user is not logged in. Boolean values are true and false. In most of the cases, you will find that in programming, we use Boolean values for managing a state. An example could be of on or off for a bulb. So on could be true, off could be false. But here, in all the examples, if you observe, every variable that I've created is storing only a scalar value or an individual value. So these are called primitive data structures. Now, in real life, in use cases, in industry, we don't deal with much with scalar values, whereas we deal with huge data sets, or you can call them huge databases, where there are millions of rows in a data. So I'll give an example of how or what kind of view of a huge data set or a database looks like. For that, I'm going to take you to another virtual machine here, which will show you how the huge data looks like. So here you can see that here in this kind of data, which will be later processed for solving the real life, you can say challenges for business based decision makings. So here we are not dealing with one word, one value, or we're not dealing with only integers, or we're not dealing with only booleans or only floats. Here it's a mixture of data spread it across in multiple lines. So the importance of data structures comes into the picture when we are faced with such kind of data where the data is heterogeneous, means it holds multiple values, and it's not a line here, means it's not a group of words, it's basically a group of millions of lines here. All right. So I think that gives a good picture of how a grouped data looks like, right? And that grouped data or the set of values is stored in non-primitive data structure and is processed using the built-in provided functions. So here, all these data structures such as lists, tuples, sets, and dictionaries are basically used to store the data, which is huge in size and is a collection, means a set of values, not an individual value or not a scalar value. Now basically list also supports a group of values or set of values. Tuples also supports that. Set and dictionary also supports that kind of value. I'll give an example of a list data structure here, which will enable you to easily understand that thing. For example, let's say I have a variable called grocery list, and here I have some items here. Suppose, let's say, pen, and here it could be, let's say, a watch, and finally, let's say, candy. So, guys, this is an example of a list basically. So, you can differentiate between a list and a variable, or you can say a primitive versus non-primitive. A variable or a data structure basically holds a single value, whereas a non-primitive data structure holds group of values, or in simple words, we call it collection as well. The similarity between all these data structures is that they all hold group of values, but where does the dissimilarity lies? Where they are different from each other? And the difference is understood only when we understand the nature of data. So, nature of data will help us in understanding what is the difference in list, tuple, set, and dictionary. Let us start from the primitive data structures in this slide here. So, in this slide, you can see that I've used or mentioned some of the primitive data structures of Python, such as integers, floats, and booleans. So basically, these integer and floats are the number types here. The examples are like age 21, salary is a variable which is holding the value of 25,000. Similarly, the float variables are temp with the value of 37.5 and tax 10.5. Float represents the decimal values, whereas integer represents the whole numbers. Then here we have Boolean data type or the Boolean data structure, which represents a state, right? So it can be either on or off kind of, or you can call it true or false. So you can use Boolean variables to store or manage the state of any given object. For example, is switched on, false or true, or is locked, false or true. So these are primitive data structures, integers, floats, and booleans. Now let us talk about the most important data structure from the primitive category, which is string. What is a string basically? A string is defined as a group of characters. So you can see an example of a string here called program. So this program is a group of characters here, or a set of characters. So it says Python essentials. Similarly, we have another variable here, provider, sorry, which is upGrad. So if I print this statement in Python, so if I say program with provider, so it is going to print Python essentials with upgrad. Now, why it is important for all of us to understand strings? The importance can be cleared when we try to understand the data analysis. So in data analysis, when we are given a data, not all the data is relevant for all of us. Many a times we want to extract a subset of a data, or you can say we want to extract the relevant information from a given string. Let us take an example of a tweet here. So let's say there's a tweet which says that Sachin scores, let's say, 115 runs. So let's say from this tweet, if we want to extract the relevant information. So let's say if I want to extract Sachin and how many runs he has scored, so the output of this extraction would be Sachin and 115. So in this example, you can see that from a given data, we are not interested in all of the data. We are interested in some of the section or some of the parts of the data. Now the question is that how you're going to extract the subsets from the given string. And this is something that we'll be understanding in our second slide here. Now, before we start with the extraction process, it is very important for all of us to understand how to visualize a string as a character array. Now, if you're new to Python, you might be wondering what an array is. An array is a group of characters. So here, I've given an example of a hello. So here you can see that hello has been splitted into small single characters here. Every character is given an identification number, which is 0, 1, 2, 3, and 4. These, these numbers are used to access individual elements. Let me give you an example here. So in this example, you can see that I have declared a variable called message. The value of this message variable is machine learning. Now here, every time when we see a string variable, we have to visualize this string variable's value as as a set of characters or as a character array, where each character will be holding a position or a number, which is also called index. The index will be used to access a specific character. So if we follow this visualization, then the letter M would be at 0 index. Similarly, A would be at 1, and C would be at 2, and H would be at 3, and I would be at 4, N would be at 5, 6, and so on. So here, if we observe the expression here, I'm using a square bracket here. Square bracket expression is used to access or fetch a specific character from the given variable. So I'm fetching a character at the index 3 of this variable. So at index 3 of this variable is h 0, 1, 2, 3. So the output of this program is h. Let us do another example of visualizing the string as an array. Let us try name equals to, let's say, David. If I try to access or print the name and its index, let's say 2, the output would be V 0, 1, 2, 3, and 4. Remember, these are called indexes. Let us move to our next slide and let us try to understand how substrings are extracted using indexes. So this section explains us how to extract a subset from a given string. This extraction of a subset from a given string is also called string slicing. Let us understand the given example to understand how string slicing works. So here I have a variable called message with the value machine learning. Now here, remember we have to visualize this machine learning as a characters array or a set of characters where each character will be holding a specific index. Let us visualize this using the draw here. So M A C H I N E, and then space will also be counted here, and then learning. So you can see here, this is the value which I've stored in the message variable. Let us assign the index number 0, 1, 2, 3, 4, 5, 6. Remember, space is also counted 7, 8, 9, 10, 11, 12, 13, 14, and 15. Now, if we execute this particular statement, print message, it is going to print the whole value of the given string. So it is going to print message. Now let us look at this second expression. Before we look at this second expression, right? So here, please observe the square bracket. Square bracket is also called index-based access. So here, I'm using an index for accessing a particular character. I'm using the zero, I'm specifying the zero index here, which means I want to fetch the zero index character. So the output of this print statement would be M. Now let us move to the another print statement and let us try to understand how this expression works. Now here, before we look at this square bracket expression, I would like to clear the understanding of how this expression works. Start index, colon, end index. And the extraction will happen till end index minus 1. What does it mean? So let us try to understand from this print statement. So here it says colon 70. I'm sorry, colon 7. So you can see that I have not specified the start index. So in case if you do not specify the start index, then it is 0 by default. Then I'm fetching the characters starting from 0 index till 7 minus 1 index. Yes, you heard it right. 7 minus 1. So Python does not fetches the characters till the 7th index. It fetches the characters beginning from starting from 0 index till 7 minus 1. So here it will be 6. So here it is going to fetch the characters from 0 to 6. The output of this print statement would be machine. Now here in this statement, print message 8 colon, you can see that I have specified the start index, which is 8. But in this expression, I have not specified the end index. So it will automatically extract the string till the last character. So if I start from 8 and till the last character, it is going to return me learning. Now this is the beauty of Python, that we can access the last character of our variable by writing minus 1. Minus 1 represents the last character of our string, which is G. So here, this negative indexing is also a feature of Python, and so on. This is called negative indexing. So the last character index is minus 1. So it is very easy for us to extract the last character from the given string. So in this example, we saw that how easily we can extract the substrings from a given string by utilizing various string slicing expressions. Let us try all these expressions in practical using the Jupyter Notebook. Let us start how to create a string in Python. So here I'm using the Jupyter Notebook for demonstrating strings in Python. First of all, we'll create a string variable here. Let's say my string with the value hello. I'm using the shortcut here for executing, or short key here for executing the cell, which is shift plus enter for executing the cell. So my underscore string hello is the right expression for creating the string variable. We have alternate expressions as well, such as my string equals to hello, which is also right, and my underscore string equals to hello, which is also right. So here we can see that I can create strings using 3 different expressions here. I can create multi-line strings using the triple quotes here. Hello, this is used to create multi-line strings. So let us print this my string here. So you can see that I'm able to print the values. Now in the next segment, we will learn how we can access the particular characters by using the indexes. So here, I'm going to create another variable called message with the value, let's say upgrad. So let us try to access the first character of upgrad value. So here we can see that we are able to print or access the first character by using the index, which is 0. We can also extract the length of this word by using the len function. So print total characters len message. So here you can see that how easy it is to extract the total number of characters from the string variable. Now we can also follow some string slicing expressions. So here I'm going to show you some of them here. So let us recall message. Let us recall message. Uh, okay, let's update the value of this variable so that we can have bigger expressions. So it is going to be, let's say, amazing Python cool programming language. So here message colon 5. So you can see here that I'm able to extract the characters from the message beginning from the 0 index till 4th index, right? Because as I mentioned in the explanation, it always goes till n minus 1 or the end limit minus 1. Let us try some more expressions here. Message, let's say 3. So this is the similar one. Okay. So you can see that it is starting from the 4th index, which is I. So I'll just help you with this. 0, 1, 2, 3, 4. So starting from the 4th index till the end of the variable. We can also specify the start and end limit. So for example, 4 colon, let's say 12. So you can see here, so it is starting from the 4th index until the 11th index, which is 12 minus 1. We can also access the last character of the index here, of the string variable here, which is message minus 1, like this. We can also extract the index of a given character. For example, let's say I want to extract what is the index, or I want to know what is the index of the character P. For this, we'll type message.index P. So here you can see that it is returning me 8, which means that the index number or the index position of P is 8. So I can also extract the substring using the index value in this manner. Message colon 8. So, okay, one more thing here. So if I do not use the print statement, so the default is print. So if I'm not using the print function for printing, by default, automatically it prints. So you can see here, P minus 1, right? Or I can show you like this, 8 colon. So it will start from P, which is Python cool programming language. We can also replace the same expression by removing the constant value and fetching the index dynamically like this. And we'll get the similar results. Apart from that, we have some cool functions and strings which we can use for various string operations. For example, changing the case here. You can see here, I'm able to change the string message into uppercase. Similarly, I have lowercase. I can also replace some words with some other value. For example, cool with awesome. So here it is not okay. So here we are not updating actually. So let's update. So we have done the demonstrations on string, and I hope you all understood what a string is and how to visualize a string as a character array, what indexes are, and how to perform string slicing. With that, let us proceed to some more complex data structures which plays a vital role in data processing. So here I'll be talking about some of the most fundamental data structure of Python, which are set, list, tuples, and dictionary. First of all, let us start with the very first data structure, which is list. So here, what is a list? A list basically represents the group of values here. So here you can see in this expression in the square bracket, we can see some set of values here. Now lists are dynamic in nature. Not only list, all the other data structures such as tuple, set, and dictionaries are dynamic in nature. When I say dynamic in nature, that basically means that the values in this collection or in this group can be removed as and when required. So we can expand this list as much as we can or as much as we want, or we can reduce the number of items in this list as well to save some memory space for better performance. So a list is represented in a square bracket expression. It allows you to store values of various data types. List is compound in nature, which basically means that it allows values of multiple data types. It is dynamic in nature, as I told you earlier, means that we can grow and shrink the size of this list as and when required. Or in simple words, we can add items and we can remove items as well. List is mutable. Mutable sounds technical probably, but it is very easy to understand. Mutable means that the list is modifiable or editable. In simple words, I can replace this smartphone with a laptop. I can replace this books with, let's say, ebooks. And I can replace this 100 with 200 or any other value. So this is called mutable. Remember, primitive data structures are immutable, means numbers, strings are immutable. So in non-primitive data structures, such as list, sets, and dictionary are mutable. And there is one more data structure which is called tuple. It is immutable. We'll be seeing that in a while. Let us do some programming demonstrations and let us try to understand how to create a list in Python and how to perform various operations using a list. Let us start. Alright, so let us start with the practical demonstrations on list in Python. As I explained earlier, list is a data type which allows you to store various data types in it. List is a compound data structure and list is mutable. So let us learn how to create a list in Python. So here, I'm creating a list here called grocery list. And square bracket represents a list here, and it is an empty list like this. Let us create a list with some predefined set of values. Let's say smartphone. Oh, sorry. So let's say spices, shampoo, and it can be anything. For example, let's say jar and cold drinks. So this is a very ordinary list here that we have created with some predefined set of values here. So I'm just going to print all the values here like this. A list items can also be accessed via indexes, similar to the string arrays. So here I'm using index to access a specific item from the given list. So here I'm getting an error because I have named it wrong here, because it is not GO, it is GRO. So it is also very important for all of us to understand how to resolve such errors. So here you can see that I'm able to access the first item of my grocery list, which is spices. I can follow all the expressions that I have learned in string slicing. So let us print total items in list. So here I'm again going to use the len function for accessing the list here. So you can see here that in my grocery list I have total 4 items. Once a list has been created, I can add some more items in it. Let us learn how to add items in an existing list. For adding an item in existing list, I'm going to use a function called append. Let us try the append function. Grocery underscore list dot append. And here, let's say we can add any item here, cups. Let us try printing the list here. So you can see that by using the append function, I'm able to add some more items in my existing list. Please observe that the item has been added at the end of my list. Let us try it one more time. So you can see here that I'm able to add one more item, painting, in my list. Let us try to add some list of or set of values. Instead of individual values, this time we'll add multiple values all at once. Extra. So here we'll create another list here called extra items equals to, let's say, rice, bread, butter. So here I've got some more items to be added in my grocery list. For this, I'll be using a function called extend. So grocery list dot extend extra underscore items. So I'm using extend function here for adding the extra items into my grocery list. So let us print the grocery list and let us check whether the items has been added or not. So you can see here that I'm able to add some more items in my grocery list using the extend function. Here we have added many items in our grocery list, and let us try to loop through our list in Python. So here we'll run a loop over this grocery list and we'll extract all the items one by one. So let us understand the syntax of constructing a loop using a list. So here, this is the expression of how to extract all the items from a grocery list into this object called item. So this object is a variable, you can say, which is holding the items from the grocery list one by one. It is not a keyword, it can be anything. So this is running a loop here. So first of all, the very first item which will be fetched from grocery list would be spices. It will go into item and it will print spices. Then the next item from the grocery list will be fetched automatically, that is shampoo, and will go inside item, replacing the old value, and it will print shampoo. Similarly, the next items will keep on assigning into the item variable or object and will keep on printing. So this circular execution will keep on happening till the times the items are present in the grocery list. Once all the items have been accessed or fetched, this loop will terminate automatically. So I'll just print it, items in my grocery list. So you can see here. So I'm just decorating a little bit here. So it's very easy, slash n is for line break actually. So you can see that using a for loop, I'm able to access all the items from my grocery list. Now, as I told you earlier that the list is immutable, or which means list is updatable. Let us do a demonstration on checking whether I can update a value in a list or not. So here, let us assume that I want to replace this jar with some other value. Let's say I want to replace this jar with milk. So grocery list, here is the grocery list, and the index of this jar is 2, 0, 1, 2. Let us try to update the second index. And I'm replacing the value jar with milk. I've executed the cell and let us try to print the list. So here we can see that previously it was jar, now it has been updated to milk. So it means that the list is immutable or editable. Now we'll check whether the list allows duplicates or not. For that, we'll add some duplicate value in this grocery list. So I'm adding butter once again. So here we can see that grocery list is allowing the duplicate values, or a list allows duplicate values. So this gives us a clear understanding of when not to use list. So if your data requires the uniqueness in it, or if your data requires the distinct elements in it, so in that case a list is not suggested at all. Now finally, we will understand how to remove an item from a grocery list. So from this grocery list, we'll be removing, let's say, spices, which is the first item of our grocery list. So let us check if the spices is removed or not. So you can see here the spices is removed. So let's do a quick revision of list in Python, everyone. So list is a data structure which allows you to store various data types in it. It is a compound data structure and it is mutable as well. List is suitable for values which are repeated in nature. Values can be added using the append or the extend function, and values can also be removed using the remove function. List can also be sliced using the slicing expressions that we have covered in the strings. And list is a versatile dynamic data structure. So the demonstrations that we just experienced were on list and that showed the various functions of list. Now in the next demonstration, we'll be understanding about the second fundamental data structure of Python, which is tuple. So let us look at a tuple, what a tuple is. Now first of all, a tuple is also represented as a set of values here. You can see that here I have some values of days from Sunday to Saturday. The major difference between tuple and a list is that a tuple is immutable or read-only. Now what does it mean? It means that once a tuple is created, a tuple cannot be modified. A tuple is also represented using the simple brackets here. On the other side, a list is represented using the square brackets. Let us do a practical demonstration on tuple and let us try to understand how to create a tuple in Python and how it works. Let us create a tuple in Python. So here, I'm creating a tuple called days with a fixed values here. So here, I have created a tuple with the weekdays. So let us print the type of this tuple. So here you can see that it is a tuple. Now the next thing, whether tuple allows index-based access or not. So let us try to access the index-based access of a tuple. So here we can see that I'm able to access the value 0, value at 0 index, which is Sunday. Let us try to print the length of the tuple. So here I'm able to access the number of elements in a tuple using the len function. As I mentioned earlier, tuples are immutable, means tuples cannot be updated or modified. So let us try to update the value Sunday or the Sunday with fun, let's say. So days 0 equals to fun. So here I'm executing the cell and you can see that it shows an error message which says tuples does not support item assignment, which is true to the nature of tuple, which means we cannot update the values of a tuple. Now tuples are used in such scenarios where the modification is not allowed by the user or by the other end. So tuples can be used in scenarios of where the security is required, where the immutability of the data is required. Because tuples are immutable, not much operations can be performed on tuples. You can see that I've got only two methods here, count and index. It doesn't provide you access to many functions because of its immutable nature. We can also run a loop over tuple, and that's it. So here in this demonstration, we saw that how to create a tuple in Python and its immutable nature. Not much can be done with a tuple in Python, but we can use tuple for securing the data or when we want the data in the read-only format. Later, we can also convert a tuple into a list form. So for example, so here this expression converts a tuple into a list. So here, editable days can be updated or modified like a regular list. And later, it can also be converted into a tuple using the tuple function as I'm using the list function here. Well, that's all in tuples in Python. I hope you have understood the immutable nature of tuples in Python. Now, in the next slide, let us try to understand sets in Python. Now, sets are a collection of distinct or unique objects. Yes, you heard it right. Sets do not allow repeated values or duplicates. Sets are useful in scenarios where we want to keep or maintain only unique elements in our data. So here, in this example, you can see that I have created a set called info. Observe that sets are represented using the curly brackets. Now, did you observe that the tuples are represented using the simple brackets and the list using the square brackets? So here, intentionally, there are some alphabets which are repeated in nature here, such as E, thrice, and A is only one time here, and E is four times. I'm really sorry, E is four times. Now, when I print the info, you can see that it is printing only the unique elements, and it is not printing the repeated ones. And here you can see that E is occurring only once. It has removed all the other reoccurrings of E or the letter E. One more thing I want you to observe in sets is that sets does not follows the order of insertion. Now what does it mean? It means that you can see here that the B, alphabet B, was added first. But here in the output, the, the B is occurring at the fourth sequence here. So the order of insertion is not followed. It is random. Sets holds distinct values. Sets are unordered means the order of insertion is not maintained. And sets are also mutable means you can also edit sets. Let us start by creating a set in Python. So here I'm creating a set with the curly brackets and with some values here. So first of all, I want you to observe the distinct nature of sets in Python. So when I'm printing the fruits, it is printing me apple, banana, and cherry. Here you can see that the apple occurrence is only once. It has removed or ignored its multiple occurrences. Let us print the type of fruits here, which is a set here. Now sets also allows you to loop through the item here. So let us try looping through a set here. So once again, you can see that when we access the items of a set, here the order is different. The order of insertion or the order of adding the elements in a set was apple, banana, and cherry. Whereas when I'm accessing the elements, it is random. It is banana, cherry, and apple. So that is why it is called an unordered collection. Once again, it is an unordered collection. Now the sets in Python also mimics the mathematical sets which we generally study during our academics. In mathematical sets, we perform certain operations such as union, intersection, and differences, and so on. Let us try some of the common operations of mathematics sets using Python here. So here, I'm creating first set here with the value A, B, and C, set 2, C, B, and let's say D, E. All right. So here we have got two sets here, set 1 and set 2. Let us try the union operation on these two sets here. So here we'll be performing the union operations here. So all chars equals to set 1, set 2. So let us print all chars here. You can see that using the union operations in the sets, we can extract all the distinct elements from both the sets, avoiding or ignoring the common elements. Let us try to perform the intersection of sets here. So here, set 1 and set 2. I think, so here you can see that in the intersection, it only returns us the common element from both the sets. So here, we will do difference in set 1 and set 2. Let us print the difference here. So here you can see that the difference operation on these two sets, set 1 and set 2, produces a new set which will contain only the elements from the first set, none from the second set. It basically ignores or avoids any element which is common in the second set from the first set. So that is why we are getting A and B, not C, because C is common in the second set as well. So this was difference. So that was the demonstration on sets. I hope you have understood how to create sets in Python, and sets maintains its distinct nature in data. So set is recommended in situations where we want distinctness in the nature of the data. For example, maintaining the employee ID or the product ID. Let us try to understand some of the more advanced data structure of Python, which is dictionary. Let us try to understand dictionary in Python. So what is a dictionary? A dictionary is represented by a key value pair. So here in this example, you can see that this is a key and this is a value. Key value is separated by a colon. Now the next question which comes in mind is what is the need of a new data structure which is in the form of key and value? In order to understand this key value pair or this key value data structure, let us try to solve the following question. So let us say I have some animal titles here, such as cat, cat, dog, 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 and panda. So if the task is to count the total occurrence of each animal, how the answer or the response would look like. So here, the count of occurrence of each animal would look like in this form. Cat, 2, dog, 4, panda, 1. So here in this example, you can see that as per the given question of counting the total occurrence of each animal gives us the following result. Cat 2, dog 4, and panda 1. So this kind of response or the data can be represented in the form of key and value. So here key can be called as cat and the value can be called as 2. Similarly, the other key is dog and the value is 4. Other key is panda and the value is 1. For holding and processing of or storing and processing such form of data, the data structure which is provided in Python is dictionary. Now once again, let us look at this example here. Lang, which is a dictionary object. Here, en is the key, English is the value, separated by colon. Please observe that here, once again, curly brackets are used for representing dictionary. In dictionary, all the keys are supposed to be unique or we cannot repeat a key. A dictionary is represented in the form of key value pair and also dictionaries are updatable, editable or modifiable. Let us look at a demonstration on how to create dictionary in Python and how to perform various operations. Let us start with the dictionary demonstration in Python. So in this practical demonstration, we will learn how to create dictionary in Python. So let us create a dictionary in Python. So here I am creating an object called languages. I'm using the key as en and the value as English. So here you can see that a dictionary represents a key value pair. Let's add some more key value pair and key value pairs are separated by comma. So here you can see that I have created a dictionary called languages. Let us print it. Let us try to access some values using a key here. Access a value using key. So the expression for accessing a specific value would be this. So here you can see that by writing the square bracket expression, I'm able to access a specific value. Let us try to add some more values into our existing dictionary. So adding value. For adding value in a dictionary, I'll be using the same expression, languages, and here I'll be writing, let's say, C sharp, and the value is C sharp, let's say. So let us verify whether the value or the key value pair have been added or not. So you can see here the key value pair is added. Now let us try to remove the key value pairs. So we have various ways of removing the key value pair. So let us try to understand few of them. So here I'm calling pop item function. So here pop item function is removing the last item from my key value pair. So to verify whether it is removed or not, let us print the languages once again. So here we can see that the C# key value pair is removed. But what if we want to remove a specific key value pair not from the end? For that, I'll be using a keyword called del and this expression. So here in this expression, you can see that I'm specifying a key which I want to remove. It will remove both key and value pair. Let us verify by printing the dictionary here. So we can see that the key value is removed for the Spanish. Let us try to loop through a dictionary. So here for item in languages, print item. Now I want you to observe that when we apply or run through a loop in a dictionary, it extracts the keys by default. So I can use this expression to extract the values. Now here I'm getting an error because I missed the S here. In this demonstration, I can simply add item here to access both key and value. Now there are various ways of looping through a dictionary, so I'm showing you an alternate way here. So for comma k comma v in languages.items. What this items function do, it returns the key here in this variable and the value here in this variable one by one. So if we print the k and v, we'll see the same output. So it is basically both the expressions are actually easy and pretty comfortable to understand. Apart from that, we have various other functions in dictionary which we can use for various purposes. For example, accessing the keys or accessing the values. You can see here by calling these functions such as keys and values, I can access the keys separately and values separately. Alright, so that was all for the second session of this Python series on Python data structures. If you have any doubts or queries, do share your questions in the comment section below. Hit the bell icon, like, share, and subscribe if you liked our explanation of the subject. Thank you for watching the video. Happy learning.